full of the universe.
All right, procedure. We are currently recording. First thing, Chris, you asked before. I did post the objective sheet for this unit yesterday. So if you go to where you find objective sheets, right, on the front page, come on. Everything okay? So there, Unit 9, chemical reactions, equations, and stoichiometry. Okay? It is, like I said, it is kind of long because this is sort of a long unit. There it is.
It's not that bad.
It's like 18, and a lot of them, like this, like down here, these are all just the kind of problems. These are all just the problems that we've done over the past couple of days. Identify, the types of reactions, that kind of stuff. So anyway, that's where we are. But today, I wanted to finish up the last type of stoichiometry problem that we were going to encounter here at the beginning part, and hopefully, if you've been paying attention, this problem should make sense. Okay, it's the next step, but hopefully it will make clear to you why we do it the way we do it. So if you flip over your slides to the back side, I believe it's the top right. Nope, not that one. There we go. Top right in the first row.
Yep.
Right? It says third stoichiometry problem. Mass relationship. All right. First, it says tin 2 fluoride is added to toothpaste to help prevent cavities. It is made by the single replacement reaction of tin with gaseous hydrogen monofluoride. How many grams of tin 2 fluoride are produced from 30 grams of hydrogen monofluoride? I will give you the equation. So it says it's made by the single replacement reaction of tin with hydrogen monofluoride. So tin is going to be one of our reactants. Hydrogen monofluoride is our other reactant. Because it's a single replacement reaction, right? Element plus compound is going to give us element plus compound. So where's the tin going to go in and connect with, or what's it going to kick out of this compound? It's going to kick out the hydrogen because that's like the kind of cation-ish one. And it's going to form tin 2 fluoride and hydrogen gas. Okay? So first things first, balance it. It's pretty easy. No, I will give you the equation. Allison, you just have to count. Just like on the quiz. I'll give you the equation, you just have to count. There it is. Alright. What are we trying to find in this problem? What are we looking for? Grams of tin 2 fluoride, right, are produced. What did they give us to work with in this problem?
30.3 grams of hydrogen monofluoride.
Grams of hydrogen monofluoride. So because stoichiometry problems are just conversion problems, right, we start with 30 grams of hydrogen monofluoride. Now, if you didn't know any better, right, conversion factor-wise, what's going to go on the bottom of this conversion factor? Grams of HF, right? Now, if you didn't know any better, you would just do this, right? And we'd be done with it. But can we do that? No, right? The example that I gave before, right? Let's say you're making a fruit salad, and you want to have the same number of blueberries and strawberries in your fruit salad. Okay? You go to the store and buy 1 pound of blueberries and 1 pound of strawberries. If you did, right, seriously, would you end up with the same number of blueberries and strawberries? Strawberries are a lot bigger than blueberries. You wouldn't end up with the same number, right? That's what we're dealing with when we go grams to grams, right? 1 gram of hydrogen monofluoride is not the same number of things as 1 gram of tin 2 fluoride because they're different masses, right? So we can't do this, as is so eloquently shown on your...
So I guess it's not like a mole ratio.
No, it's not a mole ratio. As is so eloquently shown on your slides, right? Look, road closed, my friends. You cannot go that way, right? No, cannot not go grams to grams. Not available. Okay? I drew this myself.
You understand.
Put it on the test.
I knew those.
Did draw this. Anyway, but we can compare moles to moles, right? That's a mole ratio. We've done that in every problem stoichiometry. So if we go back here, the first step to this problem has to be what? Convert to moles. So let's get rid of this, right? And then, Alex, what's going to go on the top of this conversion factor? What hydrogen monofluoride? Moles of hydrogen monofluoride. Okay? In this conversion factor, when we're converting from grams of one thing to moles of that same thing, right? What goes on the top of this conversion factor in front of moles? 1. Because this is on a per mole basis. What's going to go on the bottom of that conversion factor?
20.01.
20.01. Allison, where did you get 20.01 from?
I got it from the atomic mass.
So that makes 20.01 the formula mass for hydrogen monofluoride. Okay, no.
The FM.
When we do our math here, right? Grams cancel, and then we're left with about 1.5, right? It's pretty close to 1.5, right? It's 1.4, like 9999999 or something like that.
No. Yeah, it's
Should be.
1.49925. Yeah.
What is it?
1.49925.
Okay, that's fine.
99250.
And that's moles of hydrogen fluoride. Okay? So our next conversion factor, that's not what we want to end up with, right? We want to end up with grams of tin 2 fluoride. So our next conversion factor,
Put
what
a
has...
mole of hydrogen fluoride at the bottom.
Okay, so mole of hydrogen fluoride has to go on the bottom because that's got to get rid of, right? Then, how do we compare one part of the equation to another part of the equation? Through our what? Mole ratio. So that means on the top, unit-wise, what's going to go on the top here? Moles of tin 2 fluoride. Because this is moles to moles,
Mole ratio.
we've already established that that's going to be our mole ratio. Raj, where do our numbers in our mole ratio come from? The equation, more specifically, which part of the equation? The coefficients of the equation. Good. So, Niraj, what's going to go on the top of this mole ratio?
This one.
1 on the top, and what's going to go on the bottom? 2 on the bottom. Okay. Everyone see where I got that from?
Yes.
Okay. And then that turns out to be somewhere around like 0.75-ish. 0.7496. That's good enough. And math-wise, right, these moles cancel, so we're left with moles of tin 2 fluoride. Okay. But is this what that problem wants?
No, it wants
right?
grams.
It wants grams. So one more conversion factor, right? So, yes. I'm glad we got that on recording. So, I can show, Niraj, I can like show that like to kids next year that come in, like, look how exciting stoichiometry is. Like, I'll play on that little part right there. So we got moles of tin 2 fluoride on the bottom of this conversion factor, right? And then what's going to go on the top of this conversion factor?
Grams of tin 2 fluoride.
Grams of tin 2 fluoride.
What's with the 2?
What?
So what's with the Roman numeral 2?
Don't worry about that. It's a chemistry thing. So. Tin. Let me finish this. So,
I can't wait another 2 years.
what's going to go on the bottom of this conversion factor?
1.
1 goes on the bottom because we're converting moles to grams of the same thing. Right?
1.
Formula mass goes on the top.
I know the answer.
The answer, what is the answer?
80.99. No, but I got it.
Yeah.
Nine.
Oh, I did this 117. Oh, I won. That's my God.
Bears for tough.
Homework! That problem set that I gave you today, answers are posted online.